InSight's first task, once safely on the ground, was to release its solar panels, then capture an initial landing shot of its surroundings, and to make sure nothing's fallen off that shouldn't have, and then the deployment of its instruments. NASA's Mars Interior Exploration using Seismic Investigations, Geodesy and Heat Transport, or InSight mission, is the first probe designed to directly study the interior of another planet. It will study the structure of the Martian deep interior, allowing scientists to better understand the formation and evolution of the red planet. InSight was launched aboard an Atlas V rocket on May 5, 2018, from Space Launch Complex 3 East at the Vandenberg Air Force Base in California. It was the first interplanetary mission launched from Vandenberg. The lander is deploying 2 instruments directly onto the red planet's surface, using a 2.4-meter robotic instrument deployment arm. One is a seismometer, designed to measure microscopic ground motions, providing detailed information about the interior structure of Mars. The seismometer will take precise measurements of quakes and other internal activity on Mars to better understand the planet's composition and structure. It'll investigate how the Martian crust and mantle respond to the effects of meteorite impacts. The seismometer will also detect sources including atmospheric waves and gravimetric signals, that is, tidal forces exerted by the Martian moon Phobos. The seismometer is supported by a suite of meteorological tools designed to characterize atmospheric disturbances that might affect the experiment. These include a vector magnetometer to measure magnetic disturbances such as those caused by the Martian ionosphere. There's a suite of air temperature, wind speed and wind direction sensors, and a barometer to measure local air pressure. The other instrument to be deployed by the robotic arm is a heat flow probe, which will hammer itself some 3 to 5 meters down into the Martian soil. As it burrows down deep into the ground, it'll release a trailing tether embedded with heat sensors designed to measure temperature profiles of the subsurface and how efficiently heat flows through Mars's core, and thus reveal unique information about the planet's interior and how it's evolved over time. InSight will also use its radio to measure wobbles in the planet's rotation, which relate to the size of the Martian core. This X-band radio tracking is capable of an accuracy of less than 2 centimeters, building on previous data from both the Viking program and the Mars Pathfinder mission. That previous data allowed the size of the Martian core to be estimated, but with more data from InSight, it should be possible to calculate far more precisely the size and density of the Martian core and its mantle. Also aboard is a laser retroreflector instrument, which will allow passive laser range finding by orbiters even after the lander's retired, and it will also function as a node for a proposed Mars geophysical network. InSight is also equipped with 2 cameras. An instrument deployment camera mounted on the instrument deployment arm, which will image instruments on the lander's deck and also provide stereoscopic views of the terrain surrounding the landing site. And there's an instrument context camera mounted below the lander's deck, which has a wide-angle 120-degree panoramic field of view and will provide a complementary view of the instrument deployment area. As well as telling scientists more about the evolution of Mars, InSight will also provide new insights into the formation of terrestrial worlds throughout the solar system.
The basic idea of InSight is to map out the deep structure of Mars. We know a lot about the surface of Mars, we know a lot about its atmosphere, and even about its ionosphere, but we don't know very much about what goes on a mile below the surface, much less 2,000 miles below the surface down to the center. And this will be the first mission that's going to Mars specifically to investigate the deep inside of Mars.
We know that the Earth is habitable. We know that Mars is not. There might be something that we find out in terms of the structure of Mars versus the structure of Earth that maybe can help us understand why that is.
InSight carries a seismometer which measures the seismic waves that have traveled through Mars from Mars quakes and maps out the deep interior structure of Mars.
We're going to also have a heat flow and physical properties probe, which will penetrate into the Mars surface about 5 meters or 16 feet to take the temperature of Mars.
And it has a radio science experiment which uses the radio on the spacecraft to measure small variations in the wobble of Mars's pole to understand more about the structure and composition of the core.
InSight will be the first mission to pick instruments up off the deck of the lander and place them on the surface of Mars. I like to say that we're playing the claw game on Mars with no joystick. The seismometer needs to be installed in one place and basically not move in order to get the best seismic data.
We also have a wind and thermal shield that will then be placed on top of that seismometer to protect it further from the environment.
For the heat flow probe, HP cubed, it also needs to sit in one place, take a while to hammer itself down into the ground, and acquire the thermal measurements over a long period of time.
InSight is a mission to Mars, but it's much, much more than a Mars mission. In some sense, it's like a time machine. It's measuring the structure of Mars that was put in place 4.5 billion years ago, so we can go back and understand the processes that formed Mars just shortly after it was accreted from the solar nebula. By studying Mars, we'll be able to learn more about Earth, Venus, Mercury, even the Moon, even exoplanets around other stars.
There you heard the voices of InSight Principal Investigator Bruce Bannett, InSight Project Manager Tom Hoffman, and InSight's Instrument Deployment Lead Scientist Jamie Singer.